Hi, good morning students. So some models in that Gauss Law are left for us. So I am going to continue that. So in Gauss Law applications regarding that properties of the conductors, and in the last class we are discussed about this principle of generator, and from that we also discussed about working principle of anti-gravity generator. That means about these concentric shells we are discussing in that, right? And so let us see some more problems based on that. And after that we will go to the next part of this topic, that is charge distribution on these plates and the parallel plates combinations, right? So now let us say this. So yesterday class we discussed about that whenever you are taking this concentric shells, two concentric shells, and if they are connected by this conducting wire, whatever the charge you are giving to the inner shell, that will be totally transferred to this outer shell there, right? And moreover, that is a principle of the generator. And whenever you are taking these two concentric shells, another important principle, another important point what we discussed there, if they are not connected, for example, then potential difference between those two shells, two concentric shells, will depend only on the charge of the inner shell. So right. So based on that, I think 2 or 3 times mains questions were there based on that point there. So remember that point. In case of two concentric shells. So that now let us go to the three concentric shells. Suppose that this is one shell and this is another, and I am taking this third concentric shell like this, right? And suppose we may take any extensions for this, like suppose I am connecting this middle one to the ground here, right? And now let us suppose this some Q is the charge and 2Q is the charge, and some minus 3Q or 3Q is charged to the outer shell, right? Let us take this radius as the inner shell is R and this is 2R I am taking, and this shell is 3R, let us take here. And so now let us write this charges appearing on these different surfaces there. Once this middle shell B is connected to the ground, let's suppose this is the shell A and this is shell B and this is the shell C, we are naming like this. So when shell B is connected to the ground, we need to identify the charges appearing on the different surfaces there, right? So write that question. Three concentric shells A and B, A, B, C are shown in figure. The three concentric shells A, B, C are shown in figure. They are given charges. Q, 2Q and 3Q respectively. Q, 2Q and 3Q respectively. Find the charge on each shell or each surface. Find the charge on each surface when the middle shell B is grounded. When the middle shell B is grounded. So we know already what will happen when you are connecting a shell to the ground or any conductor to the ground. So just simply whenever you are connecting a conducting surface to the ground, simply what we will say is the potential of that conductor will become 0, right? And so here also the shell B is connected to the ground. So the potential of B should be equal to the 0 here, right? And so now I can write this as I am taking the charge on this surface. We know that the total charge given to this inner shell A will reside only on its outer surface. So those charge distributions I am writing here. This will be 0 and this is Q. And so here opposite charge minus Q will be there irrespective of this grounding. These two surfaces carries equal and opposite charges. That also we discussed already, right? And on this surface I am assuming this charge as some small q, right? And so now here again this charge will be minus q, opposite to that charge will be there. And so now this charge will be 3q, 3 capital Q plus q, this inducer charge. So the charge distribution will take place like this. So these charges what we are taking here, these charges or we are taking this as final charge distribution here. So these are the final charges what we are assuming there after grounding, right? And so now simply what we should do is we should write the potential of shell B, and we equate them to the 0. the potential of shell B. So this VB is equal to, now let us write the potential due to this different charges here. So potential due to the charge on the shell A. So for this point will become an external point. So external point means I can write that as KQ by 2R. That is potential due to this charge. And next here potential due to this net charge you may consider, or individually you may consider here. Now potential due to this minus Q if I consider here. So potential due to minus Q will be minus KQ by 2R. That is potential due to this negative charge present on the inner surface of the shell B. Similarly on the outer surface we are assuming that Q is the charge here. So that let us write that as a first here. We are assuming that let Q be the charge on outer surface of B. So that is the assumption what we are taking here. Now potential due to that charge we can write as plus K into Q by 2R, right? So that is the potential due to the charge. Now next potential due to this charge we should write here. Or for this you can calculate the net charge and you can write the potential due to the net charge here. And here also you can write like that. And so I am splitting that so that this term will be cancelled here. First term will be cancelled directly there. So now for this I am writing the net charge here. The net charge is 3Q. That means 3Q plus Q minus Q. So net charge on this will be 3Q. So I am writing directly the potential due to that 3Q. So 3Q by, that means 3KQ by, the radius will be for this point an internal point. So internal point means the potential will be same as that on the surface. So its surface means 3R we should write. And that potential should be equal to 0 since it is grounded, right? And so now let us see the simplification of this. These two will be cancelled and there you can write this as Q by 2 plus Q is equal to 0. Therefore this Q is equal to minus 2Q we can write here. So that is the charge present on the outer surface of this B, right? And from that you can write the different charges on the different surfaces of A, B we can write there, right? So that means inner and outer I am writing here. Inner surface and this is for outer surface. Now for example if I write for A. So for A if I write inner surface of A will be 0 and outer surface will be Q. Final charges I am writing here, right? And next for B if I write inner surface will be minus Q, inner surface will be minus Q and outer surface will be this minus 2Q. And so that on the B, on the C, so inner surface will be opposite to this, so it will be plus 2Q. Right, opposite to this charge, and here 3 plus Q. Q is minus 2Q, so then you will get final charge as Q. So this will be the charge distribution there. So if I ask this net charge, so net charge on each shell, so this will be Q, it remains same, and this will be minus 3Q and this will be 3Q, right? That means if they ask what is the net charge on each shell, and you can observe this shell A and C are isolated shells, that means they are not connected anywhere. So the charge on them, net charge on them will remain same. Only the charge distribution will changes. Inner, that means charge on the inner surface and charge on the outer surface will changes. But the net charge on those two shells A and C will remain same because they are not connected anywhere. Only the charge on B will changes here because B is connected to the ground. So some flow of charge may takes place between the shell and the ground here. And so that only the net charge on this B is changing, but whereas on A and C it remains same. So that is a simple concept regarding this concentric shells here. Whenever this shell is connected to the ground, so equate that potential to the 0, right? And there are certain problems like in this two shells are connected together, right? When two shells are connected together, in case of only two concentric shells, we discussed already as a principle of generator, the total charge on the inner shell will be transferred to the outer shell. But suppose if the three concentric shells are there and suppose we are connecting them, suppose inner and outer are connected together. Now let us see the charge distribution. So let us take the same problem. I am taking the same problem here. like 3 concentric shells, and additionally now what I am taking is the shell A and C are connected together. Right? Now that is additional connection what I am taking here. So this is a conducting wire. So now write that. So now write it as an next problem for us. 3 concentric shells A, B, C are shown in figure. They carries charges Q, 2Q and a 3Q respectively. Find the charge on each surface of the shell. Find the charge on each surface of the shell when B is grounded. When B is grounded, comma, A and C are connected by a conducting wire. A and C are connected by a conducting wire. Right? So that is the question now. So now here in the previous problem the net charges on A and C are remain same. Individually, charge on A will be same and the charge on B will be same before B is earthed, B is grounded, or after B is grounded. Only the charge on B is changed in that problem. But now the charge on this A and C individually will changes such that the sum of charges on A and C will remain same because they are connected by the conducting wire. And so that through this conducting wire some charge may flow from A to C, or from some charge may flow from C to A. So that the sum of charges on A and B, A and C will remain same, right? And so the charge on B will changes because it is grounded. Or sometimes they will ask a question like some charge, some switch may be connected here, and they may ask what is the charge flowing to that switch. So whatever the charge is flowing, you can calculate there, the difference between initial and final charges. And so now previously when only B is grounded, so there we written one equation like potential of B we mentioned, and that is equated to 0. Now additionally what we should do is we should write the potential of A and potential of C also, and so that since they are connected by a conducting wire, their potentials must be same. So right. So whenever the fundamental points here you need to remember is when a body is a conducting surface is grounded, its potential will become 0, and whenever two conducting surfaces are connected by a conducting wire, the charge transfer will take place from higher potential to lower potential, or from one object to another object, until they get the common potential, right? And so now here total B is equated to 0 and A and C are equated together because they are connected by the conducting wire. And so now the total charges are changing here. So then I am taking the charge present on this is Q1, and so this will be minus Q1 will be there, and this is Q2, and this is minus Q2 will be there here, and this charge I am taking as Q3. So these are the charges present on the different surfaces. So mention that let the charge distributions are Q1, Q2 and Q3 as shown in the figure. That is the final charge distribution we are taking. And so here what we can write is the net charge on the sum of the charge on A and C together will be conserved, right? So as A and C are connected together, the sum of charges on A and C will be conserved, right? And so that if I apply Q plus 3Q, this is the initial charge, and the final charge is Q1 plus this charge we need to write here. That means minus Q2 plus Q3. That will be the total charge on this shell C here, inner plus outer, right? And therefore here we got the relation, like one relation what we can write is Q1 minus Q2 plus Q3 is equal to 4Q we can write. So let it be equation 1, right? And so next let us write the potential of B. So next let us write, as B is grounded, its potential should be 0. So as B is grounded, VB should be equal to 0. Therefore that VB value we can write as, so now we need to write in terms of these charges here, these panel charges. So for this Q1, charge on the A, K Q1 by 2R, and due to this minus Q1 that will be cancelled, so it is minus K Q1 by 2R, and due to this Q2, same as that of our previous problem, this part, this term, so it is K into Q2 by 2R. And for this you can write the net charge directly, so that we can write it as plus K of Q3 minus Q2 by, it is 3R for this. So for this it is an internal point, the B is an internal point, so potential will be same as that on the surface, right? And so now if you simplify that, you will get another equation. So I can write this as these two terms will be cancelled. So here it is Q2 by 2 plus Q3 minus Q2 by 3 is equal to 0. Let us take an LCM and simplify that. So I can write this as 3Q2 plus 2Q3 minus 2Q2 is equal to 0, right? And so from this what I can write is Q2 is equal to minus 2Q3 we can write. Suppose this say this is the second equation. Next. So next what we can write is, this is another equation here. So next what we can write is, as A and C are connected together, the potential of A must be equal to potential of C. So that I am writing here, as A and C are connected by conducting wire. So therefore what we can write is potential of A will be equal to potential of C, right? And so now let us write potential of A and potential of C, you can equate them. Suppose I am writing the potential of A here. So this we are writing here, potential of A is equal to potential of B. So first I am writing the potential of A, that means for this point. So due to that K1, Q1 charge, K Q1 by R minus K Q1 by 2R due to this charge, and due to this charge, or here I can write Q1 plus Q2, sorry. And net charge I am directly taking here. So if I take this net charge, K of Q2 minus Q1 by 2R plus, similarly let us take this net charge for this one. So I can write this as K into Q3 minus Q2 by 3R. This value must be equal to potential of this C. So potential of C means for all these charges, then 3R we need to write. So I think directly you can get that, or I am writing this separately. See this, K Q1 by 3R minus K Q2, sorry, plus K Q2 minus Q1 by 3R plus K Q3 minus Q2 by 3R. So for all of them, that means for A and B, this C means internal external point only, and for these charges that will be on the surface. So you can simplify that, you will get another equation here. So for this, from this if I write, like I can write Q1 plus Q2 minus Q1 by 2 plus Q3 minus Q2 by 3. This value is equal to, and here you can observe this, here all denominator will be 3 only, you can take LCM, then this plus Q1 minus Q1 and plus Q2 minus Q2 will be cancelled. That means only what you will get is Q3 by 3 you will get. And you can further simplify and you can combine these equations and then you can solve those remaining calculations here. Like if I take the LCM here, I can write this as 6q1 plus 3q2 minus 3q1 plus 2q3 minus 2q2 is equal to, I am cross multiplying that so that you can write this as 2q3. So then let us simplify this. So then this term and this term will be cancelled, right? And so now here you can simplify this remaining terms as like, so q1 terms are 3q1 plus q2 is equal to 0. That means q2 terms are these two terms, right? And so therefore this q2 is equal to minus 3q1. So that is q2 relation and let it be equation 3. Now you need to solve that equation 1, 2, 3 there. Then you can calculate that q1, q2, q3 values individually, right? I think you can solve that, this calculation. I will do that calculation here. So those are the simple basic method, basic equations here we need to identify here. What are the equations we need to write and what we need to solve. So just you need to identify that one there, right? And so now here simply we can write that equations as from 1, 2 and 3 from these equations. So total I am converting in terms of Q2, like let us eliminate in Q2 and Q3 or you can eliminate any one of them. So I am eliminating that, I am writing total values in terms of Q2, right? So then this Q1 we can write by using this equation. So the Q1 values it is minus Q2 by 3. Minus Q2 by 3 minus Q2 and this Q3 value I can write as from this minus Q2 by 2. This is equal to 4Q, right? And then take LCM and simplify this. So I can write this as minus 2Q2 minus 6Q2 minus 3Q2 is equal to 24Q. And so this is minus 11Q2 is equal to 24Q or Q2 is equal to 24Q by 11 minus 24Q by 11. And from that you can write these Q3 and Q2 values easily. Therefore Q1 is equal to, I can write this as minus 1 by 3 into this value minus 24Q by 11 and so that you will get 8Q by 11 and then this Q3 value I can write here. Q3 value is nothing but minus 1 by 2 into minus 24Q by 11 so that I can write this as 12Q by 11. So these are the charges Q1, Q2, Q3 values. And based on that our diagram you can write the charges on the inner and outer surfaces or the net charges appearing on the surfaces you can write there, right? Or sometimes as I said by giving some switch they may ask the charge flowing through the switch. So that simply see how to answer that one. So right, suppose here this is our distribution what we are assuming Q1, Q2 and Q3 values. Sorry. So here simply this symbol, such a symbol will indicate that conducting wire is not in contact with the B, or sometimes they may represent a small hole through the B and through the small hole it is moving, or sometimes they will mention their connection like this, that indicates they are not connected there. That means this wire is not connected to the shell B here. And so the charges what we are assuming is like this. This is we are assuming completely Q2 here, so minus Q2 and this is Q3, right? And so now you can find the charge flowing through this switch here. That means initially the charge on this A is Q and this is 2Q and this is 3Q, right? They may place some switch here or they may place some switch here. So anywhere they may place some switches. Suppose if the switch S1 is connected here, I am taking in terms of a switch S1 for example, and here some switch S2 is connected here, right? So now if they ask like what is the charge flowing through the switch S1 and S2 once they are closed, then how to find means for that net charges we need to find here. And for example, simply to find the charge flowing through the switch S1 if you want to answer, that means S1 means this switch. The charge flowing through the switch S1 if you want to answer. The initial charge present on that shell B is 2Q, right? Now let us identify the net charge present on that. So net charge on shell B is equal to, so this is net final charge. So net final charge on shell B is equal to final charge on shell B. So this is QB is equal to, that we can write it as Q2 minus Q1, right? And so now this amount we can write it as, so that Q2 and these values we can substitute here, minus 24Q by 11 minus Q1 value is 8Q by 11. So 8Q by 11. And so this QB value is nothing but minus 32Q by 11, right? And so now the charge flowing through the switch is the difference between this initial charge and this final charge. Initially minus 2Q is there, now finally this amount of charge is present here. So therefore I can write charge flowing through the switch is so through the switch S1. So this will be delta. We need to find the difference between initial and final charge, the difference we need to find here. So Q initial minus Q final we need to write. So Q initial is 2Q and Q final is minus of 32Q by 11 we can write here. And so then you can take LCM and you can simplify that. So then it is 22 plus 32 you will get. So you can write this as 54Q by 11. So this is the charge flowing through the switch S1. Now similarly you can calculate the charge flowing through the switch S2 also. So for that simply you can calculate the difference between only this charge you can consider here. For example, charge present on this Q. And here generally when the charge is flowing through the switch means when they are not asking whether it is flowing from ground to sphere or sphere to the ground, just we write the magnitude of the charge. If particularly if they are asking like what is the charge flowing from ground to sphere or from sphere to ground, then you need to answer along with the sign. So you need to identify whether charge flowing is positive or negative, and finally you can take this sign there, right? And so based on that we can consider this calculation here. And if suppose if you are taking like charge flowing through the switch S2 if you want to write here, the charge flowing through the switch S2. So charge flowing through switch S2. So this charge we can write this way, this switch we can write it as delta Q is equal to, so I can write this as again Q initial minus Q final I am writing here. And so now Q initial is nothing but initially we are taking it as Q, right? Now the final charge present on that is Q by 8Q by 11. So that means how much charge is it is flowing means we can answer this as 3Q by 11. That means 3Q by 11 charge is decreasing on the shell A. When this amount of charge is decreasing on the shell A, then you can answer that that charge is flowing to this switch and that is appearing on this shell C here. You may calculate the charge present on the shell C also. That means the same calculation you can do for this shell B also, shell C also. Initial and final charges, difference between the initial and final charges of this shell C also you can calculate. Definitely will get the same magnitude of the charge will be same, right? And so that is a way of finding the charges present on the switches there when they are giving some switches like this. So fundamentally you need to remember in such a problems, whenever a shell is grounded, its potential will become 0. So that is the one fundamental point you need to remember. And the other fundamental point you need to remember is, whenever two shells are connected together, then their potentials must be same. That means charge flow will take place until their potential is same. So if you remember those two points, you can solve any problems based on these concentric shells there, right? And so then I will explain one more problem based on this. So now next let us say this problem. There are two concentric shells like Faraday R and 2R, and a charge Q is given to this shell. And now these two shells are connected to the ground like this with the help of this K2 and K1. K2 and K1. That means if that K is closed, then that particular shell will be earthed. So now write that problem. The key K1 is closed. Initially both are kept open, and some charge Q is given to the inner shell in the given system. In the system of two concentric shells shown in figure, a charge Q is given to the inner shell. Both the keys were initially kept open. The key K1 is closed first, and then K2 is closed. The key K1 is closed first, then opened, then K2 is closed. That is actual sentence there. The key K1 is closed first, then opened, then K2 is closed. So this process is repeated. This process of closing and opening the keys is repeated for n times the each key. This process of closing and opening the keys is repeated n times each. And finally the key K2 is kept closed. Finally key K2 is kept closed. Then find the potential difference between the two shells after n times. Find the final potential difference between the two shells. Find the final potential difference between the two shells, right? So initially the K1 is closed here. That is our situation then. So I will start from here itself. So when K1 is closed, so initially that shell is closed here, so its potential will become 0. And its potential is becoming 0 means we know already the charge present on this will be minus Q will be appearing here, and this will be 0. That we already discussed there, right? So that means that will be the charge distribution taking place there when this shell K1 is closed, right? Or I may consider this as a, you can write that we already discussed that. That's why I am writing it directly. Or I may consider it separately there. Suppose I am taking this as some Q2 is a present charge present on that. Suppose I am taking this as a first shell and I am taking this as a second shell, it is considered. And so now Q2 is the charge present on that I am taking here, right? After closing this. And so that we can write that as, so the potential that V2 we can write it as K Q2 by 2R plus KQ by 2R. This is equal to 0. That means Q2 is the net charge I am assuming. Some charge may be present here and some charge may be present here. Q2 is the net charge present on that shell there. And so from this you will get this Q2 is equal to minus Q. So that is nothing but what I am saying here. This Q is there, then here actually that minus Q will be there, and outside the charge will be 0. So that net charge on that shell will be Q minus Q will be there. So next what I am doing is, this K1 is opened and K2 is closed. So that is our step here. So when K1 is opened and K2 is closed. So K2 is closed means then its potential should be equal to 0 now. So I am equating that potential to 0 there. So then potential of this first shell is equal to, right? And so then here I am taking some charge present on that this shell as some Q1 I am taking here, right? So then K Q1 by R plus K of its charge is minus Q by 2R. This value is equal to 0. Got it? I am assuming when this key is closed, when inner shell is connected to the ground, the charge present on that I am assuming as Q1. Then potential due to this Q1 is KQ1 by R. On its surface only we are writing. And for this the charge is minus Q, this Q2 value is minus Q. And the potential we can write as inner point. Inner point means same as that on the surface. So that is the value there. And therefore I can write this Q1 is equal to Q by 2 we can write. So that is the charge present on that shell there. So now one step is completed. You need to remember like. So after one step, or after one time of that closing and opening the switches. So charge present on the inner shell is reduced to half Q by 2 and the charge present on the outer shell will be minus Q you will get, right? So that is the charges present on that. You need to remember that. So after first step we are getting like this. So you may repeat that, or from this only you can generalize it. So now I am repeating it again. Suppose I am repeating the situation again. And so now suppose the same situation let us consider here. I will draw this diagram so that you will get an idea here. Next again what we should close? K1 is closed and K2 is open. Now the second step, that means second time. So second time I am taking here, second time repetition. I will draw this diagram also so that you will get this clarity about this. So now which is grounded? This one is grounded here. Now K1 is closed. So K1 is closed and K2 is open. So right? And so now as it is closed, now here I am taking this charge is Q1, it will remain same which is Q by 2. And this charge let us take it as some Q2 dash. I am taking that as some Q2 dash, right? And so now this potential we need to write here. This is again R and this is 2R we need to write. And so therefore I can write that as potential of this second shell we need to write here. So K Q2 dash by 2R plus K Q1. Q1 means I am taking these values. So this is the first step after completing the first step. So K Q1 by 2, that means Q by 2 by 2R. This value is equal to 0. So remember this. The charge present on this inner shell is Q2. So that Q by 2. So Q by 2 by 2R. We are writing potential at this point. And whatever the charge present here, that charge we can't take because some charge flow will take place between the ground and that shell. So that net charge we are taking as Q2. And so due to that net charge directly I am writing that potential there. So therefore from this what we can write is, so Q2 dash by 2 plus Q by 4 is equal to 0. And therefore I can write this expression as Q2 dash is equal to minus Q by 2. So now this is the charge present on this outer shell once it is grounded. Next we are repeating that, that means we are reversing that. Next when K2 is closed and K1 is open, right? So now K2 is closed and K1 is open. I will draw the diagram so that you will get the clarity about that, which is grounded and which is. So K2 is closed means then this one is grounded here. So now the charge present on the outer shell is this Q2 dash value is minus Q by 2. And here this charge let us take it as Q1 dash. Because now the charge on the inner shell is changing because inner shell is grounded, so charge on that shell will changes there. And so now potential of that shell I am equating to the ground here. So K Q1 dash by R, this radius or R and 2R here, plus k into the charge is minus q by 2 by 2r. So this value should be equal to 0. Now let us simplify that. You will get charges present on that. So therefore I can write this q1 dash minus q by 4 you will get is equal to 0. So q1 dash is equal to q by 4. So that means after second step, so after second time, the charges on this inner shell is q by 2, that means q square I can write, and the charge on this outer shell is, so it is minus q by 2, right? So that means charges are taking place like this after the first step and after the second step. Now observe this. After completion of first step q by 2 and after completion of second step q by 2 square. So after the n step, suppose if I consider, then I can write it as 2 power n we can write. That is the charge present on this inner shell, right? And the charge present on this outer shell we can write it as, outer shell is initially it is q, now it is q by 2. The magnitude of charges goes on reducing here. So we can write that as 2 power n minus 1 we can write. So right. Therefore from this we can generalize this as after n times, so that charge on the inner shell we can write it as the final charge on the inner shell. This is q1 final charge on the inner shell after n times. So now observe this, it is q by 2 power n, right? See, observe this how we are writing. Initially after first step q by 2, after second step it is q power 2 power 2 square we are getting. So after similarly after n times 2 power n you will get. Now q2 final. So therefore this is q2 final charge on this outer shell. So initially it is minus q, now it is minus q by 2. So I can write this as minus q by 2 power n minus 1. So let us check when n is equal to 1. So 2 power n 1 minus 1, 2 power 0, 1 you will get, which is nothing but this. That means q is equal to minus q2 minus q you will get. After second time when n is equal to 2, then 2 power 2 minus 1, that means 2 you will get, so which is nothing but this. So these are the final charges on this shells here after repeating that process for n times. And so now you can write the potentials. As we got the charges, then we can write the potentials there. So I will write the potentials here. So now finally the given situation is K2 is closed. So its potential will be 0. So finally this is given here. Given finally K2 is closed. Therefore its potential, the potential of this inner shell should be equal to 0. I am writing inner and outer so that you will get the clarity about this. Next, potential of this outer shell I am writing here. So now the potential of this outer shell we can write it as K into due to the inner charge. That means this charge. This charge is Q by 2 power n by 2r plus this will be K into minus Q by 2 power n minus 1 by 2r. So right. Therefore this I can simplify this as, so kq by 2r I am taking common, and so this value is 1 by 2 power n minus 1 by 2 power n minus 1, right. So now you can further simplify this. I think I am taking this 2 power n also common. So kq by here to n power 1 into r then this value will be n, and here this value will be 2 you will get here, right? I mean this I can write as 2 power 2 by 2 power n, so that 2 power n we are taking common. And so now we need to write the potential difference between those two shells we need to write here. So the potential difference means the inner one is, inner potential is 0, so just you can write the potential difference between them. That means finally this value is V naught is equal to, this is minus k cube by 2 power n plus 1 into R. So just I am writing the potential difference between them. PDE means potential difference between the shells. So delta V is equal to, I can write this as inner shell minus outer shell I am writing here, inner minus potential outer. They are asking just potential difference, so this order is not important, just we need to write the magnitude of that potential difference there. If particularly they are asking like difference between inner and outer, then we need to take in that order only. So this finally we can write this as k cube by 2 power n plus 1 into R. So this is a final potential difference between those two shells there. So it may appear some lengthy, but finally you need to verify that how we are writing that situations there, right? So then this type of problems will be there basing on these shells. I think you got an idea how to solve problems based on these shells, right? And sometimes they may ask like energy calculations also. Let us see one problem based on this energy, or they will ask like heat energy, how much amount of heat energy is produced. Like for example, in this problem only sometimes they may ask that what is the heat energy produced in this entire process. Then we need to simply find the initial and final energies, and the difference in that energy is nothing but heat energy here. That means some loss of energy will take place in this process. That loss of energy is nothing but we need to take it as self energy there. Sorry, heat energy. So just I am taking a simple problem for this to calculate heat energy. Let us take this as R and 2R, and this is some charge Q, and this is 3Q charge is present here, right? Now these two are connected with the help of this switch S here by using a conducting wire. Now our question is, what is the amount of heat produced once that switch S is closed? So write that problem. Two concentric shells shown in figure are carrying the charges Q and 3Q. They are connected by a conducting wire through the switch S as shown. When the switch SC is closed, find the amount of heat energy produced. Find the amount of heat energy produced. Right? So now let us see the simply this initial and final energies I am writing here. So initial energy of the system. So right. So that initial energy of the system I am writing here. So the initial energy of the system is nothing but you can write it as the self energy of 1 plus self energy of 2 plus interaction energy we need to write here, right? So the interaction energy between those two charges. So this is our initial energy now. So that we can write this as the self energy of both are conducting shells only we are taking them, and so that it is like kq by 2r plus for this kq square For this k into 3q whole square by 2 into 2r plus interaction energy we need to write here. Suppose I am taking this potential at this point, and due to that charge we can write here kq by 2r is a potential at this point due to this charge. So in that potential this 3q is present here. So then you can write it as into 3q. So then let us simplify this. So I can write this as kq square by 2r plus it is 9kq square by 4r plus 3kq square by 2r. And so that you can simplify this, and you can take LCM and simplify this. So this term will be like, I can write this as take LCM as 4, and 4 means here 2 plus 6, sorry 2 plus 6 8, and this is 9. So 17 kq square by 4r you will get, right? That is initial energy. Now let us write the final energy of the system. So final energy of the system we can write it as so we know that what will happen when they are connected. So first let us write that. So what will happen when they are connected? We already discussed it. That is actually our principle of potential, that means generator. Now this, whenever you are connecting by conducting with, the total charge on the present on the inner shell will be transferred to the outer shell, right? And so that we can write it as when switch SC is closed, the total charge on inner shell will be transferred to outer shell. So, right? So that will be the situation happening there. And so that now we can write this as, so the final situation I am drawing here. So when they are connected, then the situation will be like this. So that total charge will become 4q. So that will be the final situations there. And therefore this final energy I can write this as final energy of the system. So k into 4q whole square by 2r. Sorry, 2 into 2r. kq square by 2r is our formula. So there it is, there the radius is 2r there, outer radius. Right, now only one charge is there, and so there is no interaction energy of the system there, right? So only that self energy will be there for that system. So then I can write this as 16 kq square by 4r, or one 4 you can cancel here, therefore 4 kq square by r you will get. And so now this is the heat energy produced is nothing but heat produced. So this is nothing but this H is equal to delta U we can write there. So that means some energy will decrease, or I think initial minus final you can write here, initial minus final, this delta U is nothing but. Therefore this H is equal to, I can write this as 17 kq by 4r minus, then this I am taking here, you can write this easily 16 kq square by 4r. And so this value will be finally kq square by 4r. So that will be the amount of heat energy produced there. So right. So like that we can calculate heat energy produced in such a type of problems. Like in our previous problem also we can solve that when two shells are with connected alternatively with the K1 and K2 switches. So initial energy and final energy we need to find the difference between them. And when you are getting this confusion while writing this energy of the system, you can also derive this by using our energy density concept. So by with the help of this energy density also we can write there. Simply suppose if you want to write this energy stored between them, the energy stored inside this inner shell, what is the electric field here? Electric field inside the inner shell will be 0, right? And so no energy will be distributed in this region. So energy will be, some field will be there between these two initially, and so that some energy will be there in this region. And similarly outside some field will be there, and so due to that some energy will be there, right? And finally also here potential, here field is 0 and here also field is 0 because no charge is finally present on this inner shell here. Only charge is present on the outer shell, so outside only the energy will be distributed there. And so we know the energy can be written as integral of this u into dV, where u is energy density, so which we can write it as half into epsilon naught into E square into some 4 pi r square into dr by taking some cylindrical, the spherical element here. By taking a spherical element of radius r, there you can write this energy there. Now for example, if you are writing like this, half epsilon naught into, now E means only due to this we need to write here at a distance of say r. So then I can write this as kq by r square whole square, this is E square into 4 pi r square dr, and this limit is from r to 2r, from here to here only. But whereas if you are taking outside, this is another method I am explaining here, second method. That means instead of writing this, you can also write these energy values like this. To find the initial energy and final energy I am explaining here. So now similarly this is half epsilon naught into, when you are taking outside, k q plus 3q. Now outside that field will be there due to both the charges. And so by this total x square, suppose if you are taking that as at a distance x, again we are assuming this spherical shell here at a distance of x from this. And so then it is x square 4 pi x square dx. This is again whole square, half epsilon naught e square. And now this x value varies from 2r to infinity, outside from surface of this outer shell to infinity. So then if you simplify this, you will get this term only. So whatever you are writing like 17kq square by 4r we are writing, if you simplify this entire calculation, you will get the same term. And finally also now we can write that term as only the field is there outside. So then we can write as k into 4q by x square, that is E value. Then we can integrate this half epsilon naught square into the dV. dV is nothing but 4 pi r square dr we can write. So like that also you can calculate this energy values there. So either you can follow this our as we derived already self energy and interaction energy, you can follow like that, or otherwise you can derive like this also. You can integrate this by integrating of this energy density method also, we can use that to derive the energy of the system there, right?